All right, welcome to the build. So it's moving quickly.
And their product velocity is intense. We're both pretty involved in the LangChain community.
This is going to be an industry, like the whole thing is going to explode.
The hype cycle, it's like just because you hear everybody start talking about these things doesn't necessarily mean it's the right.
Need to go back, find out more because it's really interesting.
We're both obsessed with AI and their entire stack is just pivoted to agents.
The next question that usually comes after that is like, well, I'm fine-tuning an open model.
That's the biggest thing with the latest spec.
It's an exploding distribution vector.
I'm really excited. I think everybody is. I'm not the only one.
The build. You okay?
I've been pretty sick, actually. So after I spoke to you and I had that cranking hangover and I missed the last episode, I actually just went to bed for 2 days. So
Was it like cold type of stuff or?
yeah, chills, sweats. It's like I'd eaten too much barbecue. That feeling. How are you?
Funny,
I haven't spoken to you in ages. So we had the break and
I know.
then I was sick. What's going on?
Man, it's been like a month, maybe, before Thanksgiving. Call it season 3.
Season 3. The season where I'm constantly looking at my calendar while we record. I need a personal assistant. You don't have a job right now, right?
Yeah, man. I'm in the background. I'm just doing temp agencies and stuff like that. It's funny because, I mean, still today I'm like, I don't really know, like, to hire someone. I don't even know exactly how I'd keep them busy because it's like you can do so much yourself, but also at the same time, I mean, I'm like, can be fully consumed by agents, but there's still a capacity limit on like how many agent sessions you can manage and stuff like that,
This is what people say. It's like you're going to need an agent manager to manage your agents. Speaking of agent manager, LangChain put the agent builder into open beta if anyone wants to try it, which is pretty
So
sick.
that means you don't even have to have a subscription, like a paid subscription. You can just,
I think they bill it. I don't know. They're probably just doing it for free while it's in the beta part. But I think they were talking about how it's going to be billed kind of like they do like the cloud deployments. They changed their pricing recently where it's like basically like to be more like usage based as opposed to like minutes on demand, which made more sense because like, if your agent's sitting there, it doesn't make any sense. Or
I didn't read it, but I did get hit with an invoice that I was like, oh, shit.
I love that response. Yeah, I saw that email. I didn't read it.
You guys gave me all the heads up you needed to. That's on me.
All right. Today, I'm excited to talk about this world model Jan LeCun stuff. I've been reading a bit more about it and I wanted to understand what it means. And actually, it's pretty interesting. So yeah, I want to talk to you about that. A bit of story time and maybe I can try and teach you something.
Yeah, I'm really excited about that because if you recall, one day I was kind of like, I mean, I get the general idea, but what is the overall implication? Why is this so important? What are all the details? So
that's like most things in life. I'm like, I get it, like the general detail.
I heard the words coming out of your mouth.
Like women, I get it in general, but I just lack specifics. Yes, and then you're going to do a demo, right? And I want to basically touch on GPT 5.2, the red alert, right? So do you want to start there?
I think since we've done this, there's like a full round of new models, possibly from every provider.
Yeah, everyone brought out a new model. We had since the last time we spoke. So Gemini 3, and everyone was like, "That's it, Google's won." And the perpetual like frontier model meme started coming out of like, "You're here," and it's like, all right. And then Google had the crown, and then look, 4.5 Opus came out, but basically the only thing those guys really need to do is just be good at coding and they'll be fine. I don't think actually it matters what they do, like in the model announcements, whatever. I reckon their advantage seems to be in the wrapper around coding and the enterprise revenue they've got. Whereas like,
have you seen any data? Because I've really been wondering about, Anthropic touts their enterprise and they have this enterprise market nailed down. Well, that's beyond just coding. And, they have some awesome material out there for like Claude Academy and some of these things geared towards more just general business users. So I'm really curious when they say enterprise, how much of that is Claude Enterprise, like the Claude Desktop Enterprise plan versus the API?
I am interested in that as well. So it's about 70 to 75% of their revenue comes from token-based API calls at the enterprise.
70%.
Pushed through Bedrock, so AWS and Vertex is the two channels based on this. Pardon me. But then they also are signing large enterprise deals for their like Claude Code signups and Claude Desktop and then Claude Code. For example, they signed a $200 million deal with Snowflake for effectively enterprise kind of chat GPT. Now chat GPT within OpenAI has its own enterprise sales like funnel as well to compete with this, right? And I've had pitches from them where they try and go in and basically compete with like Microsoft Copilot, right? And it's like an enterprise wide, like not just like a team, but it's like 1,000 licenses, 10,000
Right.
licenses. And they do like digital transformation stuff on the top of that. That's a lot higher than I thought, that API revenue number. But what I really want to know is, so professional, what I really want to know is what the use cases are. Ooh, did you say they acquired Bun as well?
Yeah, I did. Was it last week?
The bun in the oven. I've seen so many developers make that quip. So you know what we need to get, mate? It's Christmas, right? I really, really want to buy a nerdy Christmas sweater. Have you seen these? I should buy you one. Actually.
Is that an American thing?
I know you're the American on this podcast.
I don't know. Yeah, ugly sweaters have been a thing
Ugly
for
Christmas sweater? I don't know. I think it's an English thing, right? Like, anyway, I want to get one of those. That's a side quest, but I'll send you one in the mail. I wonder why they bought Bun. Do you know why they did that? Anthropic?
Well, I mean, you can kind of see in the background what they're doing with more at the application layer. I mean, I don't know exactly what they would say about it, but it's just they're part of the ecosystem, and the more control and tighter integration they can have, the better for them. Because I believe Claude is it's already integrated heavily. So,
Right. Yeah, OpenAI bought like StatSig a while back. They haven't really done anything. Like, I don't know, they're buying these. Like, are they just buying these companies on a whim? Like, because they've got so much cash? It's like, yeah, we can do this, we can do that. Yeah, Anthropic has around 300,000 business customers is the estimate, with 80% of it coming from like larger businesses. So like a concentration into larger companies within that number. So that was Anthropic. And then now we've got ChatGPT 5.2. Basically, apparently what happened was Sam Altman called this like code red thing, right? Where he's like, holy shit, we're not as far ahead as we probably need to be. And then they released 5.2, reportedly against the recommendations or the preferences of some of the internal teams around like, we need to do more safety testing, or we'd like to kind of evaluate it more. And they're like,
really? I didn't
apparently
see
that's what
agreement about it.
That's what has been reported, and the evidence to suggest that is the knowledge cutoff times, right? Because it comes out and then it goes from instruct to a chat model, right? And then they put a wrapper around it, which is like effectively the fine tune, or not fine tune's the wrong word, where they basically constrain it and put the safety guardrails on top. The example, we talked about it a while back, Anthropic actually publishes their evaluation set where they constrain the model as opposed to an unhinged model. The tell for that is basically the knowledge cutoff. So the knowledge cutoff for 5.1 is late, I believe, double check this, but it's like late 2024. So it's actually quite a long time ago. And the knowledge cutoff for 5.2 is like August 2025. And now we're sitting here in December, right? So that's the time differential if you think about how long it took GPT 5.1 to come out. Well, sorry, GPT-5 and then 5.1 as an incremental upgrade.
Does OpenAI publish that, or is that what people have kind of gathered? Because I actually weirdly just noticed today.
I think you can ask it because it's defined in its system prompt, I believe. Give me a second.
Yeah, and it could have just been a certain web page I was looking at, but something with Gemini 3, I noticed today it said unspecified for its date.
That's interesting.
Gemini 3.
It's usually in the model card. Yeah, so August 31st, 2025 is the ChatGPT model knowledge cutoff. It's 5.1. September 30, 2024 is the knowledge cutoff of 5.1. I don't know. It's smashing all the benchmarks. Everyone's doing reviews. We don't need to go into that. Simon Wilson's still doing his Pelican thing. I hate that Pelican thing, but it is getting better. But the only eval I do want to talk about is the one that you highlighted, which is the GDP eval. That one was very impressive. Like, you called that out to me. Do you want to?
Yeah. So they, on the benchmarks, I'm looking through it kind of like, well, I'm already skeptical. Benchmarks a little bit. Like, what does this really mean? But then you look at their improvement from 5.1 to on GDPEval, and we covered that. It was probably a couple months ago, and that was the real world work performed by people with like 15 years plus experience. And now they're saying that the agents 5.2 specifically is like 70% better than humans, I think it was.
Yeah. So just as a refresher, it's a set of specific tasks that are curated by experts in the field across 5 domains that represent about 5% of US GDP for these specific occupations. And the question or the task and the supporting materials are curated and vetted by experts in those individual areas: finance, real estate, biology, science, healthcare, a whole bunch of areas. And then the AI generated output is evaluated against a human level output that's basically blind tested against other experts from those fields. So they give like 2 responses. One's a human, one's an AI. The expert in that field doesn't know. And then they have to choose which one is better of those 2, or if they're about the same. And when we covered it, Sonnet 4.5 was the best. And it was approaching parity in terms of like most of the time, its responses were either about the same or better. But the percentage of, always better still wasn't like that high. This is different for this model, right? Its always better percentage is basically almost at 50%, which means experts almost always choose the AI model response.
Right.
And then if you add on the about the same response, it goes all the way up to 70%. So only 30%, flip the other way, only 30% of the time is an expert in the field saying, no, that response is better and that comes from a human. That's pretty incredible. Like,
that's the biggest jump I think I've ever seen on any benchmark. And they went from 38.8% wins or ties with 5.1 up to 70.9% wins or ties on GDP.
The thing that I love about this eval set or this test, right, is that because people will go, that data's out there, so you could probably just train for it. That's true to an extent, but the test is it doesn't actually really matter that that's the case. Not like the AMI, the AMI or the SWE bench or whatever. It doesn't matter if the data's out there, because the actual test is like, this is something that someone does in their job every day, and a human is evaluating if this is better or worse, like based on a response. Because it's kind of like saying, I don't care how you got to this number. I don't care if you used a calculator. I don't care if you used an abacus, but you got to the number, right? If it was a math task. It's kind of like that kind of equivalent level determination to say, well, like the real business impact or the real world impact of AI in this context is huge.
Right.
Now,
well, not to mention most of the tasks have to deal with like file inputs or outputs.
Yeah.
And when you're dealing
they're
with
like I think one was like generate a production schedule for a TV shoot, and it was and like create enough like gap based on your understanding as a film producer of what needs to be done based on this brief and a bunch of documents. I'm like, that's pretty cool.
Yeah.
That was evaluated by, say, a TV producer or someone who works in film and television and says, yeah, that's better than what a human would generally do who has worked in the field.
Right. But yeah, you're exactly right. Like, it doesn't matter if the data is out there or not, because maybe they're larger data sets or multi-step. Well, actually, all of these is there a minimum number of steps? I can't remember, but they're like,
No, there's no minimum. It's basically just like, here's a bunch of documents, here's a task, the output is X, and the output can be generate a response. It could be generate a new Excel spreadsheet. It could be generate a I think one is generate technical drawings for an engineering task. Like it's a very diverse thing. But the key factor is like these are, if it at that level, like 70%, these are things that people get paid to do every day right now, right? And if you look at the actual deployed cost of that, and we should talk about the cost of 5.2 now next on the ARC AGI benchmark. But the cost of that, it would be cents, right? And these like those tasks are non-trivial in terms of their employment kind of wage rate per hour. Like there are lots of people, 5% of US GDP are employed across roles like that. 70% of those tasks, if this is a representative sample, can be done more effectively, one shot, simple tasks back and forth by AI now. It's amazing.
Yeah. Something that I heard Jensen Huang say, and it's like so simple, so basic, but it just keeps hitting me like every single day. He was talking about if your job is the task, then your job, you'll probably be replaced. Otherwise, it's not going to be as drastic as what people think. And that makes a lot of sense when you put it that way. Yeah. And I think like in discussions we've had, we've kind of alluded to that, but that's just like a very plain way of saying like, if it's repetitive, if you're just dealing with like inputs, process, do something, take some action, produce an output, not so secure.
Yeah, we've talked about that. Like a job is not a task, right? And jobs morph, like, as your ability or the task or the required task change, your job changes, right? So I'm pretty bullish on the human. I think.
Totally. I am, but I actually think there's a lot more jobs that would fall in that category than you initially think.
Yeah, I think the thing that is often left out of the labor impact conversation is how fungible knowledge jobs actually are. Fungible, if I can use that term, or adaptable, I guess. They morph. So, the role of, say, people always use social media as an example. I used to work in the media world, so it sort of makes sense. Like social media and search came along and basically transformed the media landscape, right? And overnight, a lot of jobs became less important. A lot of people in the roles that were buying and selling ads in traditional channels kind of not necessarily went away overnight, but they definitely became less important. There were less of them over time. And then all these new social media kind of related, social and search related kind of jobs appeared. But now all of those are changing too. And those people will morph into those jobs. That's what knowledge work is. But you can't, in the physical world, you can't just like go from digging holes to, when we have a post-hole digger, right?
Right.
That's not as transferable. Yeah, and anyway, moving on to the next one, the ARC AGI benchmark was pretty stunning as well. This is the reasoning test that Francois Cholet came up with, and Greg Camrat also works on it. He talked a little bit about it on X. We can pull up the stats, but basically like 5.2 is crushing it over the top of the other foundation models. There is another verified high performer on this task now that's, I think, a fine tune or some sort of harness around the top of Gemini 3. I'll have to verify. I think they were still getting verified.
Research.
It was like a third party lab that did something on top of Gemini that was working, but they were still getting verified. So I don't know. Maybe I can talk about that next week.
Gotcha. Well,
but
Google just released a new, we can talk about it later, but they released a deep research through their API just today or yesterday. Yeah,
that was the upgraded deep research, right? And let's talk about that next, actually. I want to pull that up. But yeah, so just on this ARC AGI thing, we can pull up the actual like stats. But 5.2. So yeah, it's 52.9% on ARC AGI 2, which is around the human baseline. Humans can easily solve these tasks with an average estimated human performance of about 50 to 60%. So that's not necessarily that amazing when you consider that previously Gemini, ChatGPT 5 Pro High, whatever that variant was, basically where they juiced up all of the compute in the past, got to, I think, a higher level than this but it's the cost vertical that, the cost vector, that is the thing to consider. Previously, because these guys set a benchmark of like total compute costs, you can't go over a certain amount of compute, right, in order to qualify. I think in prior instances of them getting this level of performance on this benchmark, and it's designed to be a benchmark of general intelligence, because it's like not something you can learn. The training set's like looking for patterns. There's all sorts. It's like very intuitive, kind of high level cognitive performance that seems to be unique to the pattern of cognitive performance of humans. They got to that level with about $4,000 per task, or it was a lot. It was like in the thousands of dollars per task in compute they had to spend in order to just really go at it. So they spent like $1 million just running GPT-5 on this benchmark back when they released. Well, that was what was reported.
That's insane.
Now it's very low. Like the amount of money that they actually spent to get this is, I think it's about $10 or $10 to $20 per task. It's really low. And so the takeaway, so $15.72 per task. That's for GPT 5.2 Pro high, so high level thinking. I think this thing has like you can put it into extra thinking mode.
Yeah, they have new parameters, I believe.
Yeah, new parameters. In the past, GPT, where is it? GPT, I actually really want to pull it up. Yeah, the grand prize goal is 20 cents a task, so it's several orders of magnitude lower than that. But at $15 a task, this pace of, I guess, effectively like high quality output tokens. If you consider like not all tokens that are coming out are created equal, these are high quality tokens in terms of like they come from a reasoning model. It's set into high mode. It takes a lot of compute. It's very expensive typically. That order of magnitude cost has gone down for solving this benchmark anyway by like 390x with this release. So the implication being like if you just scale out into the future, basically any level of intelligence that you think you need to get your hands on will become incredibly cheap based on this.
Yeah, not to mention you'll be able to run it on your computer.
Yeah. Well, actually, yeah, on-device inference. Oh, that'll be interesting.
Yeah.
I don't know how big these models are because it might just be impractical.
Well, yeah, these are massive.
They are massive models.
I'm just saying, if you look at the amount of time, like I think last episode I made the comparison of what were we talking about? Some model, and I was saying this is equivalent to 01 when it first came out, or it was 03 or something,
Yeah, we were looking at that, the artificial analysis benchmarks.
Yeah, not
on this. Yeah, like the equivalent like performance on the meta benchmark. Like that was the last, like that was the open source versus 01, right?
Yeah, and I'm starting to see, not to jump to local here, but we talked about NVIDIA is making a big push on that. Of course, they have a lot of interest in that. They sell chips, so the more people they could sell chips to, whether it's a data center or individuals, the better. But they're also like Microsoft has Azure Foundry Local. They just put out MCP on Windows last week. So I really think that the local stuff, maybe today it seems kind of silly, but I think it's going to be massively impactful. I really do.
I think you're right. You are right. Because it's effectively free, right? Like you buy the chip if it's a low cost thing. Also, like it has to be fast. So I have use cases where, as an app developer, like I have to, we can't do things unless it's on device. Now, iPads, we typically build for iPads because we've got like enterprise iOS app experience. So they've got a bit more
compliance.
No, just the screen and like the people we have, they're like inspectors. They go in, so they, we can standardize and buy the hardware so we know what they've got and we juice it up. So it's got a bit more of a processor on it. But even then, like they're going into places without internet. Like if we build a core piece of functionality that's dependent on an API call for an AI response, then it will fail. Like there's just a bunch of that sort of stuff. That means on device is required. So I think you're right. I heard Gavin Baker as a VC talk about this, about his view is like the bear case for the popping of the AI bubble is how rapidly on-device becomes material to most workloads, in which case, you know, the data center build-out that's propping up the US GDP growth at the moment may come to a screeching halt when we all realize that we can run these things on the laptops in our bedrooms most of the time. I don't know if that's true. I don't think it's true because we debated this before. On-device matters. It matters when you're mobile, but I think if you have the option, you will always go for the highest quality token you can get for the cost, which means the cloud will dominate.
Yeah.
Like,
but if you have
convenience.
people will once the architecture and the infrastructure is such a hurdle, but it will be a hybrid. Like everybody will have hybrid setup, and it might be like a model router, for instance, where say I have like a host on my computer, and based on if the data contains PII, it will process it locally. If it, it's like a complex task, like that's going to be the normal.
I met a guy actually. So there are startups around that. I met a guy. I was at the All-In Christmas party on the weekend, and he runs a startup specifically around that. He's like, clean, basically catch guard for PII for anything to do with any API, any AI request you've got. It's kind of like an equivalent of like a model router drop-in piece of code, but for PII catches, which is kind of cool. I reckon like to that on device, like on local AI, I reckon that it will kind of be like RISC chips. If you know, like the RISC chip profile distribution, like the reason why RISC chips became like a dominant kind of architecture is because of the power consumption, like differential between regular chips and RISC kind of like pro CPU chips.
Should I know what that is? I've never heard of that.
Sorry. Showing my nerdy side. Basically, it's like a way for a CPU type for processing information that was a difference compared to, say, like a regular CPU in a desktop based on power consumption differences. I think it's the head of Stanford University was one of the guys who created it. But anyway.
RISC. Yeah. All right. Yeah. Okay. I was thinking risk, like dangerous. No, RISC.
Yeah.
-V.
And that became the dominant architecture because of mobile, right? And so it wasn't that all of those chips that they were competing against went away. It was we just created like 10 billion new devices over the 10-year period when that became the dominant architecture. The same will happen for local models or on-device models. We are going to create basically an ecosystem of independent autonomous robots and robotics across cars, machinery, manufacturing, and then potentially retail as well, where those will have the power constraints and they have to have intelligent, basically onboard AI kind of chips that have to be independent from, say, a cloud environment because they're operating in the world where, they have to continue being able to see if a human's in front of them and process that request and process that information correctly. That's what I reckon the on-device thing will explode in that domain.
Yeah, and then is it just Microsoft that has the NPU, neural processing unit? First heard about that when they made the announcement about using AI on all your data on your computer, and people kind of freaked out. And then they were selling computers with NPU, but I haven't heard much about that.
I don't know what their chip thing is. I don't know. I need to dive back in and read more of Dylan Patel's blog. But one thing I did actually on the chip side of things is I took a bet. We morph into like, market chat now. So I took a bet on Google. It paid off pretty well, right? One of the reasons why that did pay off is they are vertically integrated across TPUs now, and the generation of TPUs that they have coming out. And apparently Broadcom is the primary kind of partner for them on TPUs, which at the next layer down, I think TSMC makes a bunch of this shit anyway, like underneath that layer. But I don't know. I'm not an expert in the chip world. That TPU generation is now getting excellent. And you see that from the models that they're bringing out, right? VO, an image model, and also Gemini 3. They're all trained on TPUs. And they're also doing deals with other frontier labs like Anthropic. Interestingly, though, some guys did an analysis of like who's going to get the first gigawatt training data center online. And apparently it's going to be Anthropic in partnership with Amazon, which everyone thought it was going to be Grok. and XAI, but apparently those guys. But anyway, so that chip place in the market is like becoming more, I guess, accepted compared to GPUs. And everything got a bit shaky. Like they were like, oh, is this the moment that NVIDIA loses their position? Some analysis like I was listening to around that basically said Google's strategy is to basically become like the low cost competitor, right? Not take the very high margins that NVIDIA does and dominate like the effectively lower value kind of token market and flood the market with TPUs, which is interesting.
Yeah, I've heard people guess that they're just going to make everything free at some point, which would just kind of knock everybody off. And the thing is that I didn't really think about, like Google has other revenue streams outside of their like Gemini, OpenAI does not.
Yeah, they're in a tough spot, OpenAI. Like, I guess that's why they need Microsoft on side. Probably they need Microsoft more than Microsoft needs them to an extent, although I guess this is why they're pushing on 5.2. Their position in the market is secure as long as they are ahead, right? The problem they have is that these companies have massive amounts of cash on their balance sheet. And I think Gavin Baker in that interview was talking about this as well on Invest Like the Best. Reference, they'll chuck it in the show notes. They don't really get a valuation boost as a result of having that cash on their books, apparently. It was either him or another person who was commenting on this, which, unlike, say, Berkshire Hathaway or one of those companies that basically just sits on a bunch of cash until the market tanks and then they buy back in. These companies need to deploy the cash, and basically they can either buy back shares or they can invest in this next generation. So that the theory is basically they'll use that cash, flood the market, make everything free or effectively free, and destroy these nascent competitors. Nascent $500 billion kind of, OpenAI competitor.
Yeah, right.
It's cool. Like, it's kind of interesting as a massive market. You think it's complicated, but it just comes down to cost. It's just cost, quality, and speed.
I don't know.
It's always those three things. Every market's like, you can just whittle it down to those three things.
Well, that's the logical way to think about it, but it doesn't seem like it's always that way to me.
Where do you want to go next? Do you want to quickly touch on that Google deep research thing?
Yeah, while we're talking about new models
sheet
and benchmarks and stuff like that. Now, I just saw this for the first time this morning, but what I think is interesting is we've had deep research agents and different products for a long time, but has anyone really had a deep research over the API? Like,
it's a good question.
And
if they have, I've never used it. Deep research over the API. It's sort of a bit of a weird thing because usually your number one is like, it's more of a product experience, less of an API experience, right? Typically. I know that if you consider like GPT-5 Pro as a deep research or deep thinking, because it would usually come back with some sort of lengthy output, that only recently got added to the API, relatively recently.
Yeah, it's interesting. It's kind of like the same thing. People don't know how to define agents. Well, I'm feeling the same way about some of this deep research and agentic tools and agents as MCP tools and stuff like that, because at the end of everything's just going to become agentic in the background. And actually, like months ago, when I was talking about the offloading context with a llama, like that's kind of the same idea, and it's just a more advanced level. So if you look at Tom, we've become fans of Exa, I think, lately. They have if you enable some options on their MCP server, they have a deep research option within that, and that runs for a long time. And on the back end, it's like actually an agent running. So when we talk about deep research over an API, I'll have to read more about this, but I wonder, like, what is the real difference and where do you draw the line between like agentic tools? Is this an agentic tool? Is it an agent? I don't really know.
Yeah, I don't know. The way that I would typically think about that, is at least in a development context, is like, is this an API is basically like I push something here and I I'm expecting a response, like an action response, and it's typically a CRUD function, right? That's generally what an API is. Whereas if it's an agent as an endpoint, I could ask it, within the spectrum of its scope, a whole range of things, and the harness and the oversight over the top of it is much more complex and much more intricate than a regular API, right? Like the best example of that actually was the BlackRock guys when they got up and talked about how they built an agent ecosystem that all the developers could hook into, and it showed the actual core process, right? The agents and the agentic ecosystem that they had in terms of agents, and then the request comes in. But there's also authentication into data access controls. Plus, there's an LLM as a judge evaluating the response relative to their investment criteria. Are they allowed to give advice like this? Does it overstep the mark in terms of certain components of what they are like their regulatory environment? Like that's what an agentic API call looks like to me.
Yeah. Well,
and I wonder what you get back from this. Like, is it just a PDF
that they released? It's really just this blog post, and then they also, part of this release is deep search QA. So this is a new benchmark. And
actually, I was reading that. Do you want to? I found that interesting, of just how much better Gemini is at search results. Like that makes sense, obviously, intuitively. Like this is sort of like the dumbest thing to say in the world, but it's so much better at search performance than.
What I didn't see, and of course I'm curious about, is tool use. So especially when you're talking about like a research agent, well, I guess on deep research agent, Gemini, they have it built in. That's kind of the whole point. But like they're comparing against these other models that you would have to use tools. So that's with the benchmark. Sometimes I'm like, is it really apples to apples? Or I don't think, maybe I just don't dig enough, but I don't feel like I have enough information to really compare it. It's like, okay, you use tools. Well, which ones? Did you use the same tools with every model? I mean,
there are benchmarks that do that. Like Toolbench, I think does that. It's always a consistent set, right? Yeah, I don't know.
Yeah, but like on this, oh shit, I closed it. I downloaded this spreadsheet, and I mean, they have a Jupyter notebook or a Collab notebook that basically it's just a script and it runs all of these questions. But
do you want to show it on your screen?
I got to switch.
The dreaded switch. While you're pulling that up, did you see Anthropic donated the MCP to the Linux Foundation?
Yeah.
With Block, donated Goose. And what was the other one? There was another announcement from one of the other big players. Basically, I
didn't see the Goose one, though.
Yeah, it was three. It was OpenAI, Anthropic, and Block. And then they joined the Linux Foundation. Block donated Goose. And then OpenAI brought the agents MD file, which I kind of feel like is the least. That's like the dude that rocks up to a party with like, light beer. It's like, I came with a markdown file, guys.
I brought the plates.
Yeah.
Yeah.
Such a fucking, oh yeah. I did have a chuckle when I saw that. It's like OpenAI's like, God damn it. We hate MCP, but it's taken off.
Yeah. It'll be interesting. I mean, I think that's generally a good thing. They're having the MCP Dev Summit in April. They've done that every, I don't know, 6 months or less. So, Tom, you're talking about conferences. If you want to go, it's about
I'll go, man.
Yesterday. It's in New York in like April 1st, I think.
MCP Developer Conference.
Yeah, if you just Google MCP Dev Summit, I believe.
Yeah, man. I'll go. MCP Dev Summit. But do it.
That'll be a good time, and it'll be interesting because actually I bought tickets. I didn't realize that was, I think, before the Linux Foundation deal. So it'd be interesting to see how that changes. But even if you go to that site and sign up for the conference, they've already switched it over. You register through the Linux Foundation.
Yeah.
So
I don't realize, I'm looking at the timeline here. So there are 10,000 plus active public MCP servers. I'd be amazed if that isn't actually 10x that number. But that's what they're linking at here on in August, October. They have 97 million monthly downloads of the MCP SDK, Python, and TypeScript.
What are you looking at?
Just a blog post about this from that donation from Anthropic.
Gotcha.
I'll put it in the show notes.
Yeah,
but
people
97 million a month.
People throw out numbers like there's 10,000 MCP servers, and that's true, but they're like, it's so polluted. There's so few that are legit and work and are truly maintained by
our actual products.
Yeah. So as you know, I've been spending a lot of time on the MCP registry and doing a lot with that, and I've had to do so much more cleanup and sorting through things than I anticipated, because it's a jungle. It's a mess.
That'd be a good eval, actually. MCP, like quality, where like you basically just validate an MCP server against a bunch of standardized requests.
Yeah, they actually have quite a few, and it's usually MCP servers that I like to set them up as GitHub actions. So then, as I'm committing code, it runs the templated prompts, and then it makes sure that it actually calls the tools. So hopefully
actually
more people are doing that.
Well, we'll go to MCP Central, mate.
Yes, sir.
For all of your MCP delights. Yeah, I want to go to that conference with you. I was actually going to ask this on the MCP thing. Sorry to sidetrack your Google eval. Is Kimi K2 thinking, right? Is that still the best, or Kimi, is that still the best in terms of tool calling? When we covered it, they were talking about like, this is open source, the best for tool calling. And they trained in the training data set. They talked about how they injected a bunch of real and also synthetically generated tool call kind of experiential data for the model to try and specifically around MCP to try and make it really good at that specific part of the chain, right? Is that true? Or is it just, it's not? Like, is it any good?
Yeah, if you go by the benchmarks, I think that is true. But
okay.
I was having, so when I'm using Kimi lately, it's primarily like 98% of the time through Ollama Cloud. And I think it's a great product. You can't shut me up about how much I use Ollama Cloud, but lately I've been having a lot of issues with it, like slow responses, timeouts. And so it's been hard for me to even tell, because I was trying to compare with DeepSeek 3.2 came out. And I believe on paper that might be the best tool calling, but it's super, super slow. And
it's still behind Kimi on the artificial analysis meta benchmark intelligence benchmark, but only just like 66 versus 67. For an open source model, those are just amazing. Like, for what they are, really, like, it's incredible. But I did read that like there are reports that the DeepSeek team are in the throes of a new proper large scale model, despite all of the constraints that they're probably facing.
Yeah,
where maybe they went and just like mugged a bunch of gamers and stole their PCs and ripped out the graphics cards, rigged them all together.
Do you see there's a bunch of people got arrested by the FBI for exporting chips?
Yeah, I'm not surprised. It's a big deal. Like, the export control factors are actually very hard now. Like, I'm not sure if you've seen that, like the export control regulations and the changes that happen to that, where the US government, to try and kind of, there's two strategies. There's like the carrot and the stick, right? They're trying to get countries to adopt what David Sachs calls the American AI tech stack. And then they're also trying to constrain components of any advantage into the primary competitor, like back into the primary competitor, which is China. And one of the ways that they basically juiced up all of the export controls and listed entities on the entity list you couldn't export to, or you can't like deal with. and expanded that list pretty dramatically and made it pretty kind of ambiguous in terms of like, if you put an in terms of like engaging with them, for example, if you put an open source package out there, you're technically still like liable in some way if one of those constrained entities picks it up and does something with it, even if like it's just an open source package. Like that's pretty aggressive. And then I was actually doing my visa renewal stuff recently, and then you have to declare that like I had to declare that I wasn't like exposed to anything export controlled in terms of like what I would work on. So yeah, they're trying. They're really trying. It doesn't seem to be slowing them down though.
Hey, sorry about that. My
Good man.
computer's going crazy. But go ahead.
Actually, on that, so did you see Mistral came out with I think they came out with an updated dev model?
Yeah.
Now they went quiet, right? They're the French-based kind of open source model developer company backed by A16Z. They sort of pivoted away from English-speaking markets, and then they went into the rest of world. The reason why I mention it is their model was released with a customized MIT license that basically said you can't use it if your aggregate revenue is more than $20 million.
Really? So this is for Mistral 3?
Mistral 3, yeah. And the only reason I thought that was interesting is because that's a real potential poison pill, right? Around model choice. That if you're a developer or if you're a startup, like that could kill like a startup. That could kill like an acquisition deal. That kind of variable in the mix. That's pretty aggressive.
Did you mean Apache?
Is it an Apache license? Yeah,
MIT is. I'm not a lawyer, but like wide open as far as I'm aware. Maybe I need to brush up on that. But I'm looking at
Apache 2. Yeah, sorry, my
Apache,
mistake, yeah.
Apache 2.
I thought that was an interesting kind of thing. It's not something I had considered. Like, if you start building on these models, I really want to start doing like more customization of some of these.
Get yourself
and then if you get it to a point, like say as a developer or like product person, if you get it to a point where you're like, yeah, this is like prototypes working pretty well, we want to take it to production, like those variables are real.
Yeah. So they have what, 3 billion, 8 billion, and 14 billion. I thought don't they have a bigger, like a really big one?
They do. Mistral 3 large.
Okay. It's a separate, classified differently.
And there's a 675 billion instruct variant. And that's the only.
For some reason, maybe I should check it out more, but Mistral has always just kind of slid by like my radar, never jumped out and been like, oh, the new Mistral model is out. But I will say they have like a 3 billion, which we're talking about running locally and the different capabilities you can gain with local models, 3 billion, and it has vision apparently. So that's a big deal because there actually aren't a ton of those out there. I'm going to see if this works.
Actually, in the model updates, the only other one that has a couple of, I met the product manager from Archie AI when I was in San Fran on the weekend. That's an interesting kind of company. I want to check it out. They've got a couple of open source models, but they're trying to be like an American participant in the market. But it's so hard to get airtime. Like it's just like so competitive. Like you got to have a niche. Sorry, a niche is what you guys say. Mm-hmm. But I want to dive into their models. But the other one was Nous Research. Do you know Nous?
I've used one of their models because it was like specialized for tool calling. But
yeah, and I've listened to a few interviews with these guys. They are full on hardcore, like proper research nerds. Like they have some seriously smart people, and they are training like open source infrastructure, but they're also trying to develop the technology for distributed infrastructure training. So you can have basically smaller data centers, not having to have them like wired together with all of this really expensive like cable, fiber optic cable, and with the intention of developing it in such a way that it could be all the way out into a distributed compute like environment, which is really interesting, very challenging, very technical, very hard, but you could contribute your GPU to a training cluster potentially or an inference cluster if their technology gets off the ground, which paired with a token would be very interesting. But yeah,
You mean like a
seriously smart
server?
move.
Like if you have a bunch of GPUs having like a VPC connected or something like that?
Yeah, like BitTorrent, but for training.
Okay.
Training or inference. Which, for example, like if that, I checked these guys out and they had this basically model come out this week, but then they've got a network called Psyche, now Psyche. So they're obviously testing and evaluating this idea. It's not like production grade yet. It's not like taking over from data centers, but it's an interesting kind of distributed compute. You know, remember IPFS and all those sorts of things that came out a while back? Like it's kind of like that, but for AI training and inference, backed by crypto, or a crypto coin that you can then contribute to and actually.
Yeah. It might sound like really far fetched, but I've even thought with the millions and probably billions of CPUs out there, like people will start creating clusters or salvaging PCs and creating clusters. I mean, of course, I don't know how energy efficient. I mean, there's so much that goes into that, but we have so much hardware out there that's capable, especially if you're just talking about small models that do very specific things. I wouldn't be surprised if people do that, set up like that peer-to-peer type of service.
Yeah, well, check these guys out. This Hermes 4 is the model they released, and then they've got that training cluster. Apparently, like, which makes sense. The most applicable kind of use case for this is something like Teslas or Waymos or autonomous vehicles, because the chips in them are hardcore, right? Apparently, the new ones for the upgraded Teslas and even the regular Tesla. Like, I don't know if you've ever driven a car with the upgraded autonomous driving kind of software, but it's incredible. But they're just idle. They're connected devices that are idle, right? That have this juiced up GPU in them. Like a training club, like you could imagine that would be like the biggest training cluster probably in the world if you could connect them all efficiently. And that is the challenge. And then they come with their own power.
Yeah.
Like it's sort of like a mini data center. I don't know. It's got legs, no doubt. If it was possible today, Elon Musk and the XAI guys would be doing this rather than building Colossus, but maybe in the future. All right, let's get back on track, mate. I've got to bounce at 10. Did you want to talk about this Google thing anymore, or do you want to pivot to this Jan LeCun thing, and then we can get into the demo?
Yeah, tell me more about Jan, what he's doing, and what you've learned about world models. That's what I came here for.
That's what I came here for. I want to talk about what Jan LeCun has been up to. We mentioned this a while back. So Jan LeCun, one of the key people in the AI research space. This article here, or this blog post here, which I can share, or you can check it out, goes through his philosophy, Jan LeCun's philosophy, and think it's pretty critical for us to understand, or at least I really wanted to dive in and try and understand it. So I want to talk through it with you. But basically, he's a French computer scientist, been working in this field for ages. He went and worked at Meta for a very long time, right? And he's just left to start his own kind of company. He's also got a lot of research citations. This is everything that he has. So he's like an OG, like a massive OG. AI. He obviously contributed to, as part of the team, to a range of the Meta models. And I talked about this a while back when I was going through some of the media models, if you remember that bit.
Yeah.
And I have read that Meta is developing not a replacement, but the next phase of a Llama model, but it'll be closed source. Just probably saw that coming. That's yet to be confirmed, but that's what I've been reading. But they are focused on a lot of these video intelligence, segmentation, content related models. But these are now being called world models, right? So this one is one that came out, an upgrade to this. SAM 3 came out recently, and it is excellent in terms of like its ability to just one shot kind of identify objects, categorize things, give you insights and intelligence about what you're seeing in the real world. The reason why this is important is he basically says that to drive past basic LLM kind of level of intelligence and get to something that really reflects a human level intelligence or cognitive profile in a AI model, we have to get away from just prediction based on next token or length of token reflection kind of generation to what he calls this joint embedding architecture model. Now, at a high level, that joint embedding architecture is just it's like a reference space for the model around concepts that's multimodal or contextual, that is a reflection of kind of how humans, this is what I've been reading, how humans kind of go through the world and learn. Like our input in terms of bits per second through our eyeballs and our ears and, smell and touch isn't as high as the throughput you can get from like just a regular like computer. But over time, as you develop as a human, you're learning and contextualizing everything around you all of the time and building up a world model representation of concepts and things. The basic version is, and we contextualize it in our cognitive architecture with emotion and reinforcement feedback, right? So you go near a dog, as a child, and it bites you, and that hurts, and you feel fear, and then you have a reinforcement loop that teaches you something about the world, and then that happens constantly all of the time based on this like representation, this embedding architecture that we as humans have, if you can call it that, of concepts, ideas, places, things represented in the physical world and then contextualized in a kind of a virtualized environment in this architecture we have in our minds. He thinks some degree of reflection of that into these frontier models is what's going to be required to take it from what we have now to get closer to something like an AGI or some degree of breakthrough. And this is sort of like a very simple Simon representation of that, this diagram here. It's not just that there is a cosine similarity representation of words. It's an embedding that takes in concepts and references them relative to other things, away from other concepts, ideas, thoughts, experiences, etc. So that's why world models, and it seems like DeepMind is also onto this, world models are becoming more critical in the pursuit of the next breakthrough of intelligence in these models. Mm-hmm. So the not first version, but one of the versions of this from Meta is this JEPA model, which we talked about, VJEPA 2. It is... Yeah, go ahead.
No, I was just going to say that, so you're saying the core of this is it's based around a concept called joint embeddings, and everything that you kind of explained is, to me, it's like, that's how I understand just regular embedding. So what is I know that most of the time you're talking about embeddings of text, but you can also vectorize images and different types of media. So what is the like defining characteristic or difference? Is it like way more large scale than if we're just talking about like a document vector database? Is that the difference? Or
so these are all prediction models, right? All of them are predictions. LLMs predict next token with a bunch of harnesses and a bunch of other stuff. Diffusion models and video models, they have degrees of these prediction. Pardon me. They predict basically a resolution of pixels into an image, correct? Right? But it's computationally incredibly expensive. So for example, take the Take the example of like a diffusion model. It runs through basically all the variants of potential variants to resolve to its prediction of that representation of like an image.
Mm-hmm.
Whereas that's not how humans kind of That's not how we do things. We have this energy basis. So he calls them energy-based models, where the model will assign a high energy score to things that are very unlikely in the prediction matrix, and only focuses down on low energy score variables in order to narrow down the prediction space. That's like, so for diffusion models, this is sort of what we talked about when we talked about like how diffusion models work. It's fine. Like all of these things were great once we had enough compute. We could just throw compute at it, but you can't do that when you're trying to predict like the global climate, right? It's just too complicated. You need an energy efficient kind of mechanism to focus only what really matters when you do predictions. And this is like, in a theoretical sense, we're talking about like an energy-based model. But in practice, what it actually looks like, say in the context of, say, this GDPEval model, which is a video joint, so it's applied to video joint embedding predictive architecture. What it actually looks like is basically it's like trying to predict what's next or understand the world around it in the context of, say, Meta. It makes sense because they're bringing out glasses that everyone's going to have on their head to try and replace phones. But this is actually in practice how it works. They train these models by rather than getting them to actually predict every possible outcome in, say, frames. In this case, it might be frames on a model. I think it's a bit simpler if I show you. That's the actual representation here, but I think there's a better one in this article. I'll show you. I think it's down. Give me a second. I'll pull it up. GDPEval, that one. This was the first version, June 2023. Here, this visual is probably the best at explaining it. But rather than a forward back pass in a diffusion model, this is an image joint embedding model. Basically, the model is trained to predict what will be represented in multiple spaces or areas of this image. So you've got an image of a dog here, and this is the context, but half of its face and half of its neck's broken off, right? And the model then attempts to predict, based on its understanding of like a visual latent space representation of concepts, what will actually render down and make the most sense or complete the image concept within those spaces as a prediction into that image outcome of a dog, right? That's the context, that's the target. That's in an image context. This one is in a video context, so it's doing it on multiple frames at a time, and there's basically a pass, which is different to how a diffusion model works, a video diffusion or an image diffusion model works, right? This also then applies as a concept to predicting like motion in the world. Like this is what we do. Like, so if you were looking at a ball rolling across a desk, right? And it went behind a cardboard box, and you would see it as a human. You basically have a joint embedding architecture. You're like, I know what a ball is, I know what the box is, I can see that it's on a desk, and I can see the motion, and my embedding, effectively my high level embedding model could basically see what the low energy reference information is to predict the outcome of when the ball will emerge from behind the box, because as it rolls across the desk, right? Because I can use those concept of motion, concept of a ball, the fact that it's rolling at this pace to predict. And then I could basically say, all right, 2 seconds, there it is. And then it comes out the other side. That's a different way to predict, like say in that case, like what's happening in the world around me, than a diffusion model is, where it's just like going through all of the potential variations of pixels to come up with a representation. Mm-hmm. And then in some cases reasoning over the top of it. It's much more human-like in that, like, all right, these are the things that matter in this image. I can reason over, I can see the energy density of the things that matter. I can reason over what's going on using this representation, and then I can make an accurate prediction of what's going to happen out of that, whether it's based on a request, so create a video of a skateboarder jumping, or it might be, tell me what you think is going to happen to the S&P 500 over the next 30 to 60 days.
Yeah. So are world models always focused on like images and video? Because as you're showing those diagrams, I'm thinking, well, it actually took me back to even concepts from like the MIM0 paper. Mm-hmm. And then I was thinking about how maybe this would help break down some of the complexities of like a large organization even. And, I guess that's where it's like, well, that's stuff like that would not be images or video, or it could include that.
Yeah. So right now, the models that Meta have released, and these are open, like you can go and use these and try these, are video and image as a reflection of his kind of his vision, Jan LeCun's vision, and I'm sure many other researchers, right? But the applications in this case are, all right, reasoning. So there's like an application into robotics right now for, say, this video model, because there's like a prediction. It's like you have a robot that's folding clothes, and it can reason and predict, if I fold this part of the shirt this way, then it will go into this shape, and therefore the next best step to take is this, rather than having to like compute every possible outcome of like between where I am now and a folded shirt. It can focus in on more efficiently on what matters. Ultimately, it would come down to, energy, speed, quality.
Right.
But, and like say wearable assistance, like a model that's like relatively small that can accurately kind of predict or assess things. And you're riding your bike, here's an example, and you've got your smart glasses on, and it can predict, all right, it can predict ahead of time that like there's an obstacle in the road and tell you to get out of the way, or a car's, swerving into you, whatever it is. But that's just the start based on what they have built now. His whole vision based on this blog post is taking this concept and making it much more multimodal and pluralist across concepts, ideas, thoughts. Basically takes it from understanding the real world and puts it into a representation of concepts, ideas, intelligence that humans kind of have that could go across any application. It's not just, video and assessing it. It's like, this is a potential cognitive architecture for frontier models to take them from just predicting tokens or just predicting what's in an image or predicting what's going to happen, if you generate an image and do it this way, into, much closer to what we would say, when you ask a person a question and they say, I have to think about it, right?
Yeah. So did you find out the answer to, I was asking about audio.
Remind me again. I don't
So
think
I was talking.
got that memo. Was that an email that I didn't read?
Oh no. Hey, now I get to give you shit because of it. We were talking about it I was. How much context there is just in the just around you, and whether you're in an office or outside. And then I was wondering about, do these world models, is that part of the equation? Like ambience, sound that's in the environment.
So yeah, like I was saying at the start, I think we don't appreciate how much we learn and take in from our ambient environment, right? And that's the theory. This really is like this is like a combination of like neuroscience and behavioral psychology and computer science, but that's invariably true. What I don't know is what's the best combo of injection information, multimodal information into an architecture like this to get outcomes, right? For example, if you think about how we think and learn, there's a reason why, if you really want to embed something, there's a reason why we still take notes with our hand, right? There's a tactile feedback mechanism around concepts or information retention, or when you're working through stuff that embeds or builds creativity or combines ideas when you write and there's something about that. For some people, it's typing still. It's not just sitting and thinking doesn't just do that, right? There's input mechanisms around those different multimodal data feeds that do something to us that is unique around our ability to kind of process information, come up with new ideas. Obviously, they're all onto it. So these world models are becoming more and more important. I don't know if it's going to become a place where they have a world model kind of synthesis environment where they put where you would potentially put a learnt or training environment in there and try and synthesize some of these things, kind of like a massive version of Earth in Hitchhiker's Guide to the Galaxy, where it's actually like a simulation.
Yeah.
I don't know if that's where this is going. I don't know if that's the wrong representation. If it's just literally a different way of rendering and representing concepts via multimodal data and a relationship into some sort of embedding architecture that's meaningful and larger scale. But I find it really interesting. It's the first time I've been able to actually dive into like where is the frontier model space going, and this is one of the perspectives, right?
Right. And I need to, because I mean, even just to grasp the concepts that we talk about all the time. I mean, I used to sit there and read like homework, like highlight, print out articles, and I haven't necessarily been doing that as much lately, but on this I really need to. And that's probably why I'm putting it off, because I'm like, this is a big, I mean, it's called world models. It's a big world to jump into.
Yeah. So this thing I haven't touched on yet. And I think when at least when I've heard about this in the past, I'm like, oh, this is just for robotics, or it's just for things that are like, video based or whatever it is. But it's not the case. They like the whole idea around well, I guess we can call them world model architectures or joint embedding architectures, is model predictive control. When you or the model gets to a point where it's reasoning and it has identified the low energy, as in like most important information about the decision or about the prediction, it then has this model predictive control variable like factor where that internal world reflection actually acts as a simulator, kind of like a human does, where you say, look, this is the information that I've got and I'm making the decisions based on this, and getting rid of the noise. And it's that step that isn't necessarily like, I guess you can see it a little bit in reasoning traces, like that reflection step, but it's definitely not what we would call, it's not what we would call like a an autonomous kind of intellectual kind of reflection. It's more of a, I did this, what was the result? Do I need to do that again? Like a person doesn't think like a reasoning token, right? It's not the same. And what he's proposing here is very different and more like what humans do. I don't know. I think it's really cool that this is hopefully what's going to push the next frontier. On a practical basis, the reason why I was interested in it is because I work in a domain where this actually is very relevant, because in my day job, we are in the business of predicting asset prices and asset values over time in the real world. So it's real property asset price prediction is our area. Is this a frontier where some of those predictions could potentially be abstracted away or combined with a human to build better prediction models, because it is actually a reflection of some of those things? Like it's a more practical like first step, as opposed to having like concepts like, I don't know, like if you're trying to predict how Cameron's going to feel in the morning, like, I don't know, like that's a pretty high level prediction. Or, what the traffic density on the roads is going to be like in Austin. That's a pretty kind of complicated thing. Whereas like if I could use this as a combination of like real world physical things, like what's the condition of a property, what's the aspect, what are the features, those are very well known quantifiable kind of image or video concepts that can be combined into some sort of combination of prediction, potentially with this architecture that may be better than what's available. That was the other reason why I'm excited by it.
Yeah. I mean, there's certainly going to be some amazing applications. I hate to say it, but surveillance, I mean, like we thought AI was surveillance nightmare to begin with. I mean, if you just
yeah. Look, you're not wrong, man. You're not wrong at all. Like, okay, here's the model. I wonder if you could get this running. I wonder how big this is on your DGX. That's pretty cool. The place to play with these is this tool. Yeah, I can't go through one show without
RoboFlow.
I can't go through one show without showing off a workflow tool.
For something with flow in it. That's all right.
So it's it's kind of like foul or replicate, right? But with a couple of workflow overlays that enable you to build your own video or image segmentation observation models. It's pretty sick, actually, and it's a lot of fun. But if you go to the workflows and check out examples, let's go. So that SAM3 model is in there. You can detect, count, and visualize. I've seen examples of people using this to build like a game analysis model for their kids, like basketball team, that's like professional level, whether you just film it and then like tag the players, and it's good enough to just go and it'll follow them around the whole game. Like, it's pretty amazing. So here's a workflow, detect and classify. That's a pretty classic example. And then I can put your face in here and detection model, predict the location of objects within bounding boxes. I can then test it with different images. So yeah, check this out and try it. I wonder if there's just a demo example I can play with.
Says you need at 4-bit, 70 parameters, 35 gigs of RAM. I would have thought something like this was like massive, but maybe not.
Well, that's the whole idea, is also because this process focuses only on the low energy, high importance data, it's way more efficient. So that's also the promise. So you can put it into a robot arm, basically, or on a pair of glasses on your head. So offline, on device, all of that sort of stuff.
Well, I'll have to try it. ChatGPT is telling me you could probably run it on the DGX.
Probably. Yeah, here's an example. All right, so this is an example of this RoboFlow, and this is using SAM? This is really cool. Basketball players, computer vision. There's a data set, and then you can use the model, detect and classify, active learning, collect pre-annotated data while running the model. Yeah, this is really fun. Detect and classify, here we go, and create the workflow. And that's based on a set of basketball images that have been predefined. Basketball players, here we go. Detection model, data in, data out. So sick. And then you can develop an active learning target data set. Man, the amount of stuff that we can just do now with these tools is unreal. Like, for example, here's in agriculture or manufacturing. Agriculture is a great example of manufacturing as well, but like active detection of issues, active detection of like, compliant or non-compliant produce coming down a production line, anything. Like, you imagine like the cost of building something like that in the past, being able to do it custom for what you need, or just being a developer.
Yeah, I was thinking about testing drugs and like genetic, I don't know, mutations or things like that.
You probably need all of the alpha models for that, I assume, but they're not things that I know a bunch about. I'm more about, look, is this a chicken or not a chicken? That's my cognitive level. Is it a chicken? Is it not a chicken? Chicken detection and tracking computer vision model. You can keep an eye on your flock. Anyway, might leave the Jan LeCun world model conversation there.
Well, that's way more than I knew and understood. So thanks for taking the time and diving into that, because I just cloned JEPA too. So we'll see. We'll see if I can run this bad boy.
I can predict right now, mate, that if you start the demo, I'm going to have to bounce midway through probably. It'd be sick if you could still do it.
One, you kind of brought it up earlier about the security within the harness. So Anthropic, when they put out their paper about, or their blog post on code execution, there was a little paragraph that kind of explained like you could use your agent harness to filter out PII. So I have that as a demo to show how you can put like social security numbers, whatever, as input, but then it encrypts that data and it never actually goes through the LLM. It's all basically just stored and encrypted on your machine. So there's that.
Like a hash.
I got on a multimodal fantasy land here the other day, and I don't even remember how or why, but I came across Microsoft Vibe Voice, and I don't pay a ton of attention to these things as far as voice and image models, so I don't know that it's a breakthrough, but it seemed like it was potentially a big deal. And the big thing is I can run a voice agent locally, and it's actually pretty fast and it works really well. So I have an agent that uses Whisper for speech to text, then it uses Olama for the like agent response, then it sends that to Vibe Voice, and it talks to you. And it's integrated with MCP, so you can talk, and like if you use like say file system on your computer, you can be like, hey, pull up that file, tell me about it. What was, so that I thought that was pretty cool.
That sounds great. That sounds pretty fast. Do you want to show that off quickly? I want to.
Yeah,
kind of
the
want to
part
do that.
the part that's not fast about that, I can try it. I meant to have my OBS studio set up properly so that my system audio, because that's the problem is you won't be able to hear it. I need to feed in, and that's why I can do it. So I can do it on a different video and make sure I have the audio right. Because I would have to. There's so many, especially with like voice agents. There's so many additional things above and beyond just regular agents, like even the echo canceling, and like noise. Like you have to dial. You can't just necessarily implement it. You have to have it calibrated right. All your settings, all the interrupts. Like you don't want your agent just reading an entire paper and not being able to stop. So like how you insert or inject like your interrupt without losing the whole conversation and it just going on some other tangent. So it's an agent that I've had for a long time, but it was using Whisper and Google for the text to speech. And now I have it running 100% locally on my computer. So I'll show you that one. And then what was the other one? I had something. One of these days, I'm actually going to set up another monitor because that's what. If you see me looking backwards,
looking over your shoulder,
screens are all messed up. What was the other one? Tool search, which is very similar to code mode. We talked about probably a couple months ago. So Anthropic put out a new concept or paper about essentially, it's right along the lines of how agents.md and skills and subagents, even how those are like, you have your skills are referenced in your Claude.md file, and then you might have subagents doing the same. So you're not injecting all of that context right away. It only calls it when it's needed. So they have a thing that I scaffolded up, and so that's another one. But the two Anthropic ones that I mentioned, those are on the build GitHub. So yeah, so anybody can go out there and I think it's set up like pretty straightforward.
They all sound great, man. So I'm going to have to jump. Do you want to just record them? Because I can always upload them to edit. Do you want to just record them? And then we can just add them to like one to this show and then one to next week and one to the week after. And that way you can just bang them out.
Yeah, exactly. And I just need to do it with a different app than the one we're using here because they don't have a lot of good options for audio. So I need to use like OBS or something else.
Yeah, just do it locally and then send it to me and I can fix it or I can sort it out or append it. So yeah, I think that'll be good, man.
Cool. Oh, the other thing, what's it called? WAN 2.2?
Yeah. So what is WAN 2.2? Like, so
that's your stuff, man.
Was that the cartoon one? Is it just the one that makes cartoons? I don't know. I can't keep track of all of these.
It's a video model. It's Alibaba. And WAN, they have like a couple different that you can run text to video.
Yes.
Speech to video. And then the animate, WAN 2.2 animate is where you can take a video of something and then take an image of like you, and then it replaces the person in the video with you. So that is, I can run that on my DGX. And what's amazing, so this is kind of funny because just to do text to video, it takes about an hour and a half to create a 3-second video. So I was like doing the math. It's like, oh man, in one day I could generate a minute or like 50 seconds, which is like nothing. But I was experimenting with setting up a script so that you could say like generate videos that are 3-second frames at a time, and it just runs for like the entire day back to back to back, and then combine that with the Vibe voice, generate the audio. So that's what I was trying to get. I actually didn't spend a ton of time on it, but I was hoping that I would get that completely finished.
Yeah. Man, that's what, like, I'm never going to buy a DGX. I'm just going to use SF Compute. If I would ever to do this, I can just rent a H100 GPU for $1.45 per an hour at like last minute prices.
Yeah, right. if you're going for productivity and like max horsepower, don't do that.
Or just convenient.
Yeah. Well, I'm very interested in the local systems and stuff like that, as you know. I mean,
yeah,
I always have been. So
I'm playing.
No, I know. For me, it's like just trying to understand the boundaries and timeline and what's possible. I know you said what I can show you just real quick is these are 4 videos that I created from a script. So I had GPT just I said like action, create the frames for an action film, and it just did like whoops. So this 12 seconds took about 6 hours.
And then you have to make an edit. You're like, oh, I kind of want to edit. Gives you a sense of when you use something like Replicate, like how many servers are just like roaring to life on your behalf.
Exactly. It puts it in perspective. And also, if you ever, or anyone out there, like, what was it called? Stable Diffusion. A lot of people were running locally. So that was just generating images. And so it's funny, you can sit here and be like, oh my God, that's ridiculous. 3 seconds for an hour and a half. But if you think about, I don't know, like a year ago or a year and a half ago, that was blowing people away, just being able to generate, and they were not very good images. So this is actually pretty amazing, I think.
The fact that you can just do it locally, I guess that's the if what we were just talking about comes to fruition, right? And there's a mechanism to remove the information and the prediction components of, say, these video diffusion models, video models that predicts the next sequence of images, right? And then stitches them together in a hyper efficient fashion because it's only predicting the component parts that need to be predicted, right? And it's more accurate effectively because it has like a better kind of reasoning or cognition engine behind it. Then you should be able to do this locally. Like, say, a model like that. You saw how small the JEPA model, the video JEPA model actually is. That's not a video gen model, like it's a categorization kind of prediction model, but you could see how it would be combined, or you could combine the functionality of those together potentially. Then a DGX might actually be like overspec'd.
Well,
in that environment.
If you're doing, like I said, you could generate 50 minutes of video in a day. So think if you're just doing like some type of promo videos, like 15 seconds, well, you can make like 5 of those scripted out. Like you said, have it kind of like dynamic and do different iterations or variations. So you could do like, quite a few variations in one day if you're just making short little videos. So I still think you could do quite a bit with this. Or if you want to do the initial testing and kind of get it outlined and then go burn up more tokens on a cloud service. I mean, I don't know.
Yeah, the hilarious part of this is like the main thing that this is being used for is just to generate videos of like you and your friends doing crazy shit on Sora. So like useful token out or useful prediction out. So much of this is just completely useless. Hence why like Google is just like, yeah, well, we don't care. It's just ad inventory for us eventually. We're just going to absolutely flood the market with available tokens because our business model can leverage that. OpenAI probably has to go like, yeah, Sora's fun, probably burning so much cash. Maybe they should lean a bit harder into the science, business, high quality output token or high value output token.
Yeah.
All right, mate, I've got to run. This has been fun. Do the demos. I want to see the demos. But it's good to talk to you again. Sorry, I was away.
Yeah, have a good one, man. Bye.
Bye.
All right. Open to the build.